The diagram shows two blocks at rest, connected by a light inextensible string which passes over a smooth pulley. Block A of mass 3 kg rests on a rough plane inclined up 30 degrees to the horizontal. Block B of mass 5 kg rests on a smooth plane 50 degrees to the horizontal. On either side of the pulley, the string is parallel to the line of the greatest slope of the plane, and block A is on the point of sliding up the plane. So the whole thing's going to move this way. So we want to find the tension in the string and the coefficient of friction between block A and the rough plane. Okay, so if we draw the diagram, okay, I'm going to write up here, this is rough and this is smooth. Okay, so we've got the weight acting downwards on this block here, so it's 3G newtons. We've got the normal reaction, when I call R1. We've got the tension in the string, and because it's got a tendency to move this way, there will be a friction, which is F is equal to mu R1. For the 5 kg block, we've got the weight acting downwards. We've got the normal reaction, so I'm going to call that one R2. And we've got the tension in the string, but we've got no friction because we're told this is a smooth slope. Right, so we need to find the tension in the string. So the easiest one to do is to consider block B, if that's the only thing to do. So we've got resolving along the 50-degree plane, we've got the weight. We want the component of the weight. So if we draw the little triangle, we want this one here. So that's going to be 5G sine of 50 minus the tension is equal to 0, so that will give me the tension is 5G sine 50, which will give me 37.53, taking G as 9.8, which is 37.5 newtons. Part B, we need to find the coefficient of friction, so we'll need to look at block A. We'll need to find R1. So resolving perpendicular to the 30-degree plane, we're going to have that, again drawing it in, we're going to have R1 minus 3G cos of 30. This angle is 30, this will be cos, this force is what we want. It's equal to 0, so R1 gives me 3G cos 30. We don't need to work that out at this stage. Now, if we resolve along the 30-degree plane, so this way, so we've got T minus the weight here, so it's going to be 3G sine of 30 minus the frictional force, which is equal to 0. So we've got T from this part, don't use the one that you've rounded off though, minus 3G sine 30 minus mu, which we have to find, times R1, which is 3G cos 30, and that's equal to 0, and that will give that mu is going to be equal to 37.53 minus 3G sine 30 divided by 3G cos 30, which gives you 0.8968, which gives you 0.897, correct to three significant figures. So this has been a video to show you how to find the coefficient of friction of a connected object where one plane is smooth and one plane is rough. I hope you've understood, and I thank you very much for watching.